welcome to the fifth crash course of IAS Chemistry Unit 1 Topic 1. So in the previous videos I did Topic 1A to Topic 1D. So in today's video is the final video of Topic 1. We'll be doing the final topic, Topic 1E. So to start off with, we are going to start off with molar volume calculation. So what is this molar volume? So molar volume is the volume occupied by 1 mole of a gas. So 1 mole of a gas will always occupy this a constant volume provided the temperature and pressure stays the same. So at room temperature and pressure, so 298 Kelvin, 100 kilopascals, the molar volume or how much volume 1 mole of a gas occupies at room temperature and pressure is 24,000 centimeter cube per mole. Each mole 24,000 centimeter cube, or we can write it as 24 decimeter cube per mole. So it is the same for all gases. Any gas, 1 mole of any gas has the same volume, provided temperature and pressure stays the same. So amount in moles equals volume over molar volume. So that is the equation we have to remember for molar volume calculations. Moles equals volume over molar volume. So we'll have to use this equation in many of the calculations. So we'll use an example. So in this example, a piece of magnesium mass 1 gram is added to excess dilute hydrochloric acid. What is the volume of gas formed? Hydrogen gas formed. So the equation they have given, balanced equation. This is the balanced equation. So then we first have to calculate the moles of magnesium. So that is the limiting reagent. So we calculate the mole of magnesium. So that is 1 over the molar mass, which we can find using the periodic table, is 24.3. 1 over 24.3 gives us this amount in moles of magnesium. So then we check the equation, and magnesium to hydrogen gas, they are in the ratio 1:1. So therefore we can say that the same amount of moles of hydrogen is formed. So 0.0412 moles of hydrogen is formed. So then all we have to do is we use this equation, amount in moles equals volume or molar volume. We use that equation, rearrange it so that we get volume equals moles into molar volume. So moles, we have the moles of hydrogen gas into 24 dm cube. So then we'll get the answer in dm cube as well, 0.99 dm cube. So this much of hydrogen is formed. So then that's it for molar volume calculations. Now we'll move on to concentrations of solutions. So so there are two types of concentrations mainly we use. So one type is mass concentration. So that is usually given in grams per decimeter cube. So mass per unit volume. So that's mass of a solute in grams. Solute is the substance we dissolve, over volume of solution in dm cube. So an example, we have 200 centimeter cube of a solution contains 5.68 grams of sodium bromide. So this 5.68 grams of sodium bromide is our solute. What is this mass concentration? So mass concentration, mass of solute over volume of solution. So that is 5.68 grams over, we have to convert this 200 centimeter cube to decimeter cube by multiplying it by 10 to the power minus 3. So 5.68 over 0.2 decimeter cube gives us 28.4 grams per decimeter cube. So then we move on to the other type, the more common type, which is molar concentration. So molar concentration is the amount in moles per unit volume. So or in symbols it's C equals NOV. So for example, a student has 50 grams of NaCl, sodium chloride. So what volume of a 0.45 mole per dm cube solution can he make? So in the first step, so we are given the value of we are given the mass of sodium chloride, and so and we can check the molar mass of we can check the relative formula mass of sodium chloride using the periodic table. And so then after that we can calculate the amount in moles. So we use the mole equation. Mole equals mass over molar mass. 50 over the molar mass is 58, and formula mass is 58.5. So then we have 0.855 moles of sodium chloride. So uh, then we have to use the equation C equals NOV. So now we rearrange it so that we get the volume. So we need the volume here. So we rearrange it so we get volume. So V equals N over C. So N we just found 0.855 moles over the concentration. They have mentioned the concentration 0.45 moles per dm cube. So you have to make sure the units are consistent. They are in dm cube and moles. So then we substitute those into this and we get the answer 1.9 dm cube. Next, calculations from equations using concentration. So in this example, magnesium, an excess of magnesium is added to 100 centimeter cube of 1.5 mole per decimeter cube hydrochloric acid. So this is the equation. So they are asking what mass of hydrogen is formed. So first we have to, so we are given V 100 centimeter cube, the volume and the concentration. So using that, we can find the number of moles of hydrochloric acid. So we rearrange C equals NOV so that we get N. So N equals V into C. But here it's in centimeter cube. So we have to convert it to decimeter cube. So that's 0.1 decimeter cube into 1.5 moles per decimeter cube. So then we get 0.15 moles of hydrochloric acid. So then after that we check the ratio of hydrochloric acid to hydrogen. So here we can see hydrochloric acid to hydrogen, the ratio is 2:1. So 2 moles of hydrochloric acid forms 1 mole of hydrogen. So the number of moles of hydrogen is actually is half of the number of moles of hydrochloric acid. So we can use the ratio to work out that it's half the number of moles of hydrochloric acid. So the half is 0.075 moles. So then the last step, to calculate the final mass of hydrogen, we rearrange the mole equation. So moles, yeah. So then we rearrange that to give us mass. So mass equals moles into molar mass. So molar mass of hydrogen gas. Remember, hydrogen is gas, so it exists as H2. So so its final formula mass, molecular mass is 2. So 0.075 into 2 gives us 0.15 grams of hydrogen gas. So next we move on to concentrations in parts per million. So parts per million is the amount of parts of like a substance in 1 million parts of another substance. So we usually refer to parts as mass or volume. We usually use both for both. We use either masses or volumes for both substances. So we use parts per million when we are trying to express really small concentrations, like concentrations of gases in the atmosphere. So then how do we do it? Using masses. So concentration in parts per million equals mass of the solute over mass of solvent into 10 to the power 6, or into 1 million into 10 to the power 1 million, or 10 to the power 6. So in this example, a solution contains 0.176 grams of solute dissolved in 750 grams of solvent. What is the concentration in parts per million? So the units are the same, so the units will cancel out. We have to make sure the units are the same, so they cancel out. And so the values can be directly substituted into this equation. So we substitute that, multiply it by 10 to the power 6, 235 parts per million. Then we move on to concentration in parts per million using volumes. So in this example, so volume concentration in parts per million is the volume of the gas over the volume of air. So air is a mixture of different gases. So so in this example, some Nitrogen dioxide gas with a volume of 1.5 dm cube mixes with 10,000 dm cube of air. What is the concentration of nitrogen dioxide in parts per million in the air? So both as the units of both these values are the same, they are both dm cube, so we don't have to worry about the units, so we can just directly substitute them into the equation. So then 1.5 dm cube over 10,000 dm cube into 10 to the power 6 gives us 150 parts per million. That's the end of topic 1. So hope you all learned something, and thank you.